Hey everyone, let's start with data abstraction. So, in the last videos, you have gathered some detailed basic knowledge about data modeling, what are the different types of data models, how they are important, and how they are being implemented in day to day life. So, starting with data abstraction. So, database systems are made up of complex data structure. So, do you want to know all about it? To ease the user interaction with database, the developers hide internal irrelevant details from users. This process of finding irrelevant details from user is called data abstraction. So let's take an example. A car designer draws the concept and structure of the car to be built. The next engineers design the details that help convert the basic concept into a structure that can be produced. Okay. And finally, the engineering drawings are converted to production specifications to be used on the factory floor. So, see, there are three levels: car designer, other designers doing the design. Then some people are generating the engineering drawings to use in the factory floor. There are each level have their own independent level of abstraction. Okay, and they're independent to each other and the way of viewing the product also. And none of them cannot accomplish their perspective independently. Correct? So this is what data abstraction is. Now let's see the degrees of data abstraction. So this picture here, end user is in the external model view. Then you have conceptual, then internal, and then physical model. And this is how in the table the degree of abstraction is represented and the characteristics as well. So the internal model, you already know about the data abstraction, correct? I just told you. The internal model here is similar to the logical level and conceptual model is similar to the external level. So for example, let's say we are storing customer information in a customer table. Okay. So at the physical level, these records are described as blocks of storage in the form of bytes, gigabytes, terabytes in the memory. So these details are often hidden from the programmers. So at the logical level, these records can be described as fields and attributes along with their data types, their relationship among each other, which can be logically implemented. And programmers generally work at this level because they are aware of such things about the database systems. Got an idea about the physical and internal model? Now let's come to the external level. So external level, user just interact with the system with the help of a GUI or the graphical user interface and enter the details at the screen that they are not aware of how the data is stored and what data is being stored. Such details are always hidden from them. So these are the three types of labels which are important in data abstraction. Okay, so there are again two terms, logical and physical independence. So logical data independence, it encloses the ability to change the internal schema without changing the conceptual schema. Okay, and this is one example I have given. And physical data independence, which lies in between the internal and physical model, it is the ability to change the physical schema without changing the internal schema. These are the different terms that you must know about. Then here this is one external model for a tiny college system. This is your student registration. This is your class scheduling. So it's in the format of your Crowfoot diagram of the entity relationship model. So student, enroll, class, course are the entities, and these are the types of relationships in between them. Likewise, your class scheduling. Let's start with conceptual model. So what is conceptual model now? A purely conceptual model stands at the highest level of abstraction, okay, just concerned about the external presentation, and focuses on the basic ideas or concepts that are explored in the model without specifying the details that will enable the designer to implement the model. For example, a conceptual model would include entities, their relationships, and it may even include at least some of the attributes that define the entities, but it would not include attribute details such as nature of attributes in the format of text, numeric, etc., or the physical storage requirements of those attributes. I'm going to show you one picture of the conceptual model and how it's related to the internal model. See, the professor entity. So this is the conceptual model, correct? You just see the entity. But in the internal model, you have the programmers which write the code or the SQL program for the creation of the professor with its individual attributes. Same for class, for room, and for course as well. So this is the SQL code. Next comes internal model. It is the representation of database as seen by the DBMS, more close related to the physical model. In other words, internal model requires the designer to match the conceptual model's characteristics and constraints to those in the selected implementation model. Next, physical model, which operates at your lowest level of abstraction, describing a way that data are saved on storage media such as disks or tapes. Here are some of the characteristics about each of the level: external, conceptual, internal, physical, their degrees of abstraction, their focus, and how they are independent of hardware and software. So that's all for this chapter 2, data models.